Good morning, or almost afternoon, I guess. How's it going? You can try that while we're waiting for everyone. You still have 6 minutes, so no worries.
I just want to say that I'm babysitting right now, so I'm gonna be a little bit like in and out.
Okay.
Okay.
I just put up a warm up while we're waiting for everyone else. Can you see my screen? Yeah. All right. Welcome. Happy Monday. I hope you guys had a great weekend. So I put a warm-up up for you while we were waiting for everybody to get here. It's just find the LCM and GCF of 15 and 20. And then I want to answer any questions you guys might have about the LCM and GCF assignment. So first do that, and then we can talk in just a couple minutes. All right, so let's talk about this. How'd you do with the LCM and GCF of 15 and 20? And by the way, did you get my videos that I sent you last week? Yeah, did you watch them? I mean, they're not stellar videos. I'm not getting any awards or anything, but it's informational, right?
They were helpful.
Okay, good. That's all they're supposed to be. I'm not into big production value, right? It's just info. Okay, so who wants to explain either the GCF or the LCM or both of 15 and 20?
I could explain the
Okay.
LCM. So I did 2 rows. So I started with 15 and I just went up the number. So I did 15 times 1 equals 15 times 2 is 30 times 3, 45 times 15 times 4 is 60. And then I went up to 20 since I already know that 20 is just kind of like multiples of 2. I just went up until 20 times 1 is 20, 20 times 2 is just 40, 20 times 3 is 60, and 20 times 4 is 80. So I circled them. So 15 times 4 is 60, and then 20 times 3 is 60. And so that's the lowest common factor, it's 60.
Nice. Wait, did you just say lowest common factor?
I'm sorry, least common factor, I'm sorry.
Wait, did you just say least common factor?
LCM.
Help Bethel out.
Yep,
Least common multiple.
least common multiple, I'm sorry.
Yeah, be careful. Remember that word factor versus multiple get us every time. These are multiples because remember they're larger than the given value, or at least equal to that given value. So the LCM is 20. Your procedure was terrific. Nice job. So the LCM is 60, meaning both 15 and 20 are factors of 60, right? They divide them evenly. Excellent. Did anyone use a different strategy besides just listing? Madison, what'd you do?
So I did the method that you showed us after class, and I did the Venn diagram little guy. I can kind of show it. I don't know. It's going to be hard to see. Can you see that?
Yep.
Yeah. So I did the prime factorization of 15 and 20, and broke that up into 5 and 3 for 15, and then 5 and then 2 2s for 20. And then I put them in a Venn diagram to see if they had any common factors, and they had 5 in common. And then I just put the rest of the factors that they didn't share. So I had 3 on 15 side and then 4 on 20 side. And then you said that so the LCM is multiplying everything in the Venn diagram together. So that's how I got the least common multiple. And then do you want me to say that how to get the GCF from here?
Yeah.
For the greatest common factor, you just look what they share in the middle. That's the greatest common factor, which is 5.
Nice. And so that's just a visual method to do this. Some of you always tell me you're visual learners. So if you are a visual learner, you might like the Venn diagram method to get the answer. And there's a way to double check to make sure we're right. Does anybody remember what it is or know what it is? Tyler, what do you think?
Okay, sorry, I was trying to figure out how to unmute. The way to check it is you can multiply the least common multiple by the greatest common factor, and then multiply the 15 and 20. And if they match, then you're going to have a verification.
Very nice. If you multiply the two numbers that you're trying to find the LCM and GCF of, and then you also multiply your LCM and your GCF, these two better match. If they don't match, you did it wrong. Okay, so that's a nice verification step. So the Venn diagram is a nice way to go. You don't have to do it. You know, it's not often taught in elementary school, but it's a great strategy. Okay, so any questions on your LCM or GCF worksheet? Because you actually had to find either the LCM or the GCF if you use that strategy on the worksheet. Can anyone figure out which problem this would apply to from your worksheet?
I actually have a question. I'm not too sure if it's the same problem, but I have a question about number 5. Because I kind of used both the LCM and the GCF in a way, but I don't know, it's a little bit confusing. I'll just walk you through how I solved it.
Sounds good.
So first I listed the multiples of both 4 and 6, but I stopped once they reached 60. And then both of them, they had 12, 24, 36, 48, and 60 in common. And so I just counted those numbers that they had in common, and there was 5 times that they were the same. So my answer was 5, but I feel like that's not really the LCM. So that's kind of where I was like confused whether to put LCM or GCF in the box.
That's a great question, McKenna. So the answer to the problem doesn't have to be the LCM or the GCF, but it's what number you used in the finding the answer. And so you use the value of what to find the answer. What helps you find the answer? So let's talk about 4 and 6, right? Let's talk about 4 and 6. What's the greatest common factor of 4 and 6?
The greatest common factor is 2.
It's 2. And then what's the LCM of 4 and 6?
The LCM, well, it's 60 in this case, just because we stopped at 60.
So
right?
tell me the real LCM. Like, what's the least common multiple between 4 and 6? The smallest number they both divide evenly.
12.
Yeah, it is 12. So
Okay, I was
you're
working
right.
the other direction.
You're right, McKenna, that you used a common multiple of 60, right? You used a common multiple of 60, but you didn't really use it because it was a common multiple. You used it because it said, how often do they blink the same time in 60 seconds? So do you think that even though you might not have used it, which idea could we have used to find the answer? Would it be the GCF of 2 or the LCM of 12? Can anyone figure that out? Where that 12 might come in?
I still don't really know, to be honest.
No, I'm glad that you're saying you don't really know, because I bet a lot of people don't know.
Is it how many 12s are in 60? Because 60 seconds and 60 minutes in an hour or whatever.
That's exactly what it is. Because if you think about it, we're really looking at 12, because at every 12 or multiple of 12, that's when they blink at the same time, right? So they blink at the same time at 12, they blink again together at 24, they blink again together at 36. That's where you were getting those numbers from, 12, 24, 36, 48, and 60. So you were using the least common multiple of 12, even though it's not your answer. So you could have done, even though you didn't have to, 60 divided by, sorry, I wrote 15 because I'm on this slide, 12 is 5. So 5 times is when they would blink at the same time. Does that help, McKenna?
Yeah, that makes more sense now.
Yeah,
Thank you.
so it is the LCM. You were correct, it's the LCM, but you didn't really use it to solve the problem, right? But it was there.
Right.
All
Okay.
right, good question. Any other questions on that worksheet?
Roxanne, I have one question about number 7. I think I was just kind of confused on like how to solve it, but I think I just don't know if if we were solving for the GCF or LCM.
And what was the question on number 7?
It was like looking at the hat, amusement park, and like every second visitor gets a hat, 7th gets a t-shirt, and then 10th gets a backpack.
Okay. And so how did you find the answer?
Well, I tried finding the I tried to do the little Venn diagram thing, but none of them shared a factor besides 1. So then I just multiplied them together not all together, but I found I don't know, I got 70 though somehow.
Yeah, so is this what your Venn diagram kind of looked like up at the top here? Am I still sharing my screen? Okay, good. So they don't have any factors in common besides 1. So you did just multiply 2, 5, and 7. And when you multiply 2, 5, and 7, you get 70, which is the least common multiple of 2, 5, and 7, right? So every 70th visitor gets all 3 prizes. Yeah? So you're good. That help?
So my question is, if they don't share they don't have to share a factor if they don't share a factor, are you just pretty much finding the least common multiple? Is that the hint here?
Sometimes the greatest common factor is 1, right? Between 2 numbers, but when do we need that? Probably not very often, right? All right, good. So are you feeling better about that worksheet, everyone?
I have one more question.
I'm ready.
The problem that you just wrote out, was that number 7?
Yeah.
How come you did 2, 5, and 7 instead of 2, 7, and 10?
Oh, because I wasn't paying attention, because I was trying to listen without looking at the worksheet.
Oh, okay. I just thought
So,
maybe I did it wrong.
Was it 10? So if
Yes.
it was 10, then there actually is a common factor, not that all three share. Hold on. Sorry, I'll start over now that I'm listening. So 2, that wouldn't go there.
Would it go in between the 10 and the 2, right? 'Cause
It would be. So if this is multiples of 2, this is, or factors of 2 and factors of 10, and this is factors of 7, then that would go there, the 5 would go here, the 7 would go here. Does that look better? Yeah, it's nice when I use the right numbers. Thank you for getting me back on track. Okay, you feeling all right? Yay, excellent. And when you turn that in, you're showing all your work on a separate sheet of paper. Yes, you're not trying to cram it in that little area because that is irritating. Yeah, I know you're like, why don't you just make more space there? No, why don't you just follow directions? Right, we're good. Okay, this week, let's talk. Boy, oh boy, your final exam is coming quicker than we want it to, isn't it? You're like, I feel like, how is this possible? Yeah, 8 weeks, crazy. So, and we're just starting fractions. We're going to hit fractions hard, hard, hard until the end. We will bring decimals in, but when we do our decimals, we're going to be doing fractions as well. I should have your final exam oral questions by this week for sure to you, so you can get started on those and you can take a look at them. But make sure you're asking questions and you're really, really attending to precision on your assignments this week. Also notice that you have new partners this week. Did anyone notice that? You have a partner pair project. And if you want to know who your partner is, you can look on Canvas. I wrote them all down. Listen carefully. You ready? One of you better remember of the partners. Karina and Sydney, your partners. Essie and Alyssa, your partners. Vanessa and Betty, your partners. Hannah, L, and Brianna. Jessica and Karen. Evelyn and Bree. Tristan and Amanda. Michaela and Sarah. Tyler and Hannah Miles. Kelsey and Elena. Bethel and Sunita. And McKenna and Madison. If you can't remember, you can look on Canvas. Okay. That being said, that partner pair project is due next Monday. Yeah. So I know that things are crazy in everybody's lives right now. People have doctor's appointments. People are going out of town. People have memorial services to go to. People have been sick. I mean, a million different things. So keep in communication with your partner so you know what's happening and how you can get your assignment done. You don't ever have to meet, right? I don't care. Just share a doc so you can get it done. Make sense? I'll try to put you in those groups so you can communicate with them, but you can, I have my chat open. You can privately chat with your partner right now, right? There's nothing that says you can't. Okay? Questions?
I have
Yeah.
a quick question about the review for the next midterm. Is it going to be like the mid review before where it's just statements on what we need to learn, or is it going to, okay.
Yeah, and then you had the online part, right? You had the more part too.
Yeah, that one.
Yeah.
If
Yeah.
we are struggling on one of the statements, is it okay if I like come to your thing and ask you and you give me like an example of that one?
Absolutely.
Okay, cool.
For sure. That's a great idea. You guys can also schedule a study session, not about your oral midterm questions, right? But about your Canvas portion questions. You guys can schedule a study group and you can invite me, right? And then I come and I'm like, yeah, I'll answer your questions. So sometimes students plan for like 2 hours for their study session. And they're like, let's ask her to come the second hour after we've already figured out what we know and what we're so confused on and what we need help on. Okay. Okay. I think we're going to skip this for now. You can go through the slides. I'm going to put a bunch of stuff in the slides for you. We're really going to talk about fractions and what they mean today. I'm going to break your idea of what fractions are. So be prepared. Okay. Remember our productive struggle with the candy factory? Yeah. Okay. I'm not sending you to a different base for fractions, but I am going to kind of bend your ideas. Okay. So be prepared. This is just true. This is the Rational Number Project, which was all about how students learn rational numbers, AKA fractions, right? So children learn best through active involvement with multiple concrete models. You guys were only given one model most of the time. And so I'm definitely going to break that of you. Physical aids are just one component in the acquisition of concepts. Verbal, pictorial, symbolic, and real world representations are also important. Look at this. You probably never did this. Children should have opportunities to talk together and with their teacher about mathematical ideas. Amazing, right? You're not just little computational machines, right? They need to understand things. And curriculum must focus on the development of conceptual knowledge prior to formal work with symbols and algorithms. So, fraction frustrations. I want everybody to write in the chat some kind of challenge, frustration, or what they've seen or what they anticipate with kids teaching fractions to children. So what makes fractions so difficult, maybe for you or for kids? So get that ready in the chat. Okay, all right, guys, got some frustrations? Okay, let's do a 3, 2, 1, go, and then read them all. Okay, so read through them. Yeah, so you guys, you can see the frustration. Some of you have those same frustrations. And I like how someone pointed out that division can be confusing as part of it as well. Like, what's happening? Is it division? Is it not division? You know, what is it meaning? So this can be very, very challenging for students. This is a great question. How many numbers do you see here? Get it ready in the chat. How many numbers do you see here? Everybody have an answer? Okay, 3, 2, 1, go. Look through here. Look at those things you see there. You see 2, you see 1, you see 3. You see some people saying, okay, 2 digits, 1 number. Jessica's like, I'm just gonna write what the value is, 3/5, right? She's like, I don't know what game we're playing here. I don't like it. So do you see why there's a problem? Yeah. How many numbers are here? Kids have a huge misconception, and apparently maybe we do as well. how many numbers are here, and it's the way we're thinking of things. So you can think of, most of us have this first model in our head, the part whole model. It's 3 out of 5, right? So they see 2 numbers, it's 3 out of 5 of them. So then here's the problems with this model. How would you interpret 5 over 3? How can I have 5 when there's only 3, right? And then how would you interpret 8 over 3 over 5? What does that mean? 8 out of 3 out of 5. So this can be problematic, right? You're like, I don't even understand what that's saying. Remember complex fractions from algebra? That's what we're talking about with this right here. That's what this means. Do you see how that can be troubling? If you only have a part whole definition in your head for what a fraction is, this is going to break you, right? You're going to be broken at this point. So you could have a ratio as an idea. Okay, 3 boys for every 5 girls, right? And that could be fine, but do you see the concern there? It implies a multiplicative or a proportional relationship that might not be explicit for students. They might not understand what that's really saying. Instead, they might be stuck in the part whole model, 3 out of 5, when if it's a ratio, it's 3 boys to 5 girls. Yeah. And then sometimes we can think of it as division, 3 divided by 5. If that's your only model, then you're in trouble too, right? Because then you don't understand ratios and you don't understand the part whole model. So most of us were not even taught all 3 of these, especially not together. And none of them are really complete alone for sure. So here's an example. Children have difficulty internalizing what the symbol for a fraction represents a single entity, right? Is 2/3 1 or 2 numbers? Many would say that the symbol represented by 2 numbers. When students consider 2/3 as 2 numbers, then it makes sense to treat them like whole numbers. For example, when students add fractions, which somebody brought up here, they just add the numerators and add the denominators. After all, if they're separate numbers, I can do that, right? If I don't have a concept that they're connected as a value, we have a problem. Okay, and so they're interpreting the symbols as 4 numbers. They're just adding 2 numbers on top and 2 numbers on the bottom because they're saying they're whole numbers. So many errors with fractions can be traced to students' lack of mental images for the quantity the symbol represents. In other words, if you can't draw a picture for it, you probably don't know what's happening. Okay, so what's a fraction? If this, I'm going to use the word unit a lot, and the unit means the whole, 1, right? The whole unit. So if this blue bar is the whole or the unit, create a bar that's equivalent to 1/5 of this whole. Well, you can cut it, right, into 5 equal pieces, and then one of those pieces is 1/5. Makes sense, right? We're okay. Everybody's all right. We're like, oh good, there's rectangle. I can do rectangle. Okay. Here's a cut and copy idea I want you to think of. Imagine a circle cut into 4 equal copies. 3 1/4 copies are shaded. Write a fraction that says how much is shaded and all, and draw a picture. We should be okay with this. We're going to draw a circle. We're going to cut it into 4 equal pieces, and we're going to shade 3 of those pieces. And so our fraction of how much is shaded altogether is 3 out of 4, or 3/4, or 3 copies of 1/4. Yes? Okay, try 2 and 3. I think you can read them, can't you? Okay, try those 2. All right, are you doing okay? Are you like, oh, good, I understand this. We're doing good so far, right? So far, so good. Perfect. So imagine a rectangle cut into 5 equal copies. 4 1/5 copies are shaded. Write a fraction. Tell how much is shaded in all. Draw a picture. And then a rectangle is cut into 7 equal size copies where 5 of the copies are shaded. And then a rectangle is cut into 7 equal size copies where 0 of the copies are shaded. So I'm hoping yours looks something like this. Am I correct? Any questions, concerns? We gotta go in the water slowly, right? We're just wading our way in.
The 0 out of 7, that would be written just final answer 0 out of 7, right?
Yeah, when we're describing this, yes,
Okay.
we want to say there's 0 copies of 1/7.
Okay.
Okay, so what, Hannah?
I did panic for a second with B. Like, I know it's 0 out of 7, but I was like, oh no, what if it's just 1? But obviously 1 would be 7 out of 7. But I did have a moment there. I was like, not really sure.
Right?
Is that what the kids would struggle with, or is that just you're muted?
When they go through this process, they will get frustrated and they will start to question, but that conversation is great. You have them sitting at a table, you have them with whiteboards, they're drawing pictures, right? Rectangles are easier to draw than circles, just so you know. So they're drawing rectangles and they have that conversation with each other, right? They go, wait, 0 out of 7. And some kid will just say, that's just 0, right? And another kid will go, but it seems weird. Right? What if it's 1? And then hopefully that conversation comes up, Hannah, where they go, no, if it was 1 whole, that would mean all 7 of these are shaded, right? And you're walking around facilitating this as they're doing this activity. We did it really, really fast. This in a classroom would be very slow, right? Okay. I want you to do this now. This bar is the whole unit or 1 whole. Using this bar, make it so it's, sorry, I feel like I have this written very poorly. So if this bar is 1 whole, can you draw a picture that shows 13/9? So using this bar as 1 whole, draw a picture that shows 13/9. I'm gonna let you think about it, struggle for a minute. Okay, so think about it, 13/9. Okay, does everybody have an idea? Hold them up to the screen. Let me see those ideas. Everybody hold them up. I know, Hannah, it's hard when you're electronic. It's okay. All right. Some of you didn't hold anything up. Nice, Sunita. So those of you, good job. Those of you that are sharing, those of you that aren't sharing, tell me what's wrong. Ask the people who drew a picture a question. You can ask any of the questions you want.
If there's
you
only
get?
9 spaces, how are you supposed to make 13 shaded?
You're
I-
gonna have more than
Blows my
9.
mind. I don't know how to do that.
So the 13 out of 9 means you have 1 whole plus some. So I drew 2 sets of 9 and I filled in 13 pieces.
I would have never thought that ever.
Yeah, because 9/9 is basically like 1, like a whole.
Figured that. Okay.
Nice. So, and Jessica's saying, I was confused because it said, you know, create a bar. So she didn't think she could use another bar. So remember how I said, I think this wording is a little troubling. I agree with you, Jessica. I didn't love that wording. So let's look at this and see. I'm guessing what most of you did was the first thing you did was split this into 9 pieces. Yes? Because you knew that this whole must be out of 9 because our denominator is like the copies, right? Or how many spaces we have. So we're going to split this into 9 pieces. So how many lines did I draw if I wanted 9 pieces?
8
8.
lines.
8 lines. That, believe it or not, is an important step here to know that, right? That's an important thing to know because kids will start drawing 9 lines. And if they draw 9 lines, they actually have 10 pieces. Yeah, so you really have to work your way through that with kids. Okay, and you don't start with 9, by the way, right? You're in college. I started with a harder number. You start with the 4 on the page before. So once I have this, I can see that I have 9 copies of 1/9, right? For one whole unit. And then a lot of you are like, ooh, I need to add more pieces, right? I need 4 more copies. So you probably drew another bar, right? Or you said, oh, look, this piece is 1/9. So I could just go, there's 1, there's 2, there's 3, there's 4. And now this whole bar is 13/9. Yeah? Some of you are like, I felt better about them being separate. Right? That's fine. That's totally fine. Okay. Okay, so
Roxanne, I have a quick question real quick.
yeah.
For kids, I don't know, when I was first taught fractions, my teacher always told me to change that into, isn't that called a mixed fraction? Just for visuals, so you can see like, oh, I have 1 whole of, 9 out of 9, and then, 4 and 9. So yeah, mixed number. So I was taught to always change those and never keep it like that.
Yeah, and that teacher was really breaking something that she should not have. So teachers never allowed this to be an answer, right? This was not allowed to be an answer. You always had to make it a mixed number. But then when you got to intermediate algebra, everything you did, you had to use improper fractions, right? You couldn't use mixed numbers on them. So, and your teacher kept telling you that this was simpler than this. I'm here to say, no, it's not simpler. It's different. I agree, it's different, but by no means is it simpler. Okay, because now I don't just have a fraction. Now I have a whole number part and a fraction part, right? That's troubling. So, and most teachers who teach that have a limited capacity for their model of what fractions mean. And they were probably taught that way as well. And so that's the part whole idea, right? And that's why Alyssa was like, wait, we can't have 13 when we only have 9. It's because we're stuck in this part whole idea. A lot of you were like, we just have more than 1. Yep, we do. We just have more than 1. But I don't have to write it like this. I can leave it like this. Thinking of this as 13 copies of 1/9 is very important. I feel like there's a rectangle missing right here. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There should be one more. See how there's 4 down here? But there's only 3 right here. I don't know why that is. That's annoying. It's okay. It's really there. I'll fix it. Okay. So I'm so happy you said that, Madison, because we're going to talk about that. And when we describe 3/8, we could say partitioning, where 3/8 is 3 1/8, where 1/8 is the amount we get by taking a whole, cutting it up into 8 equal parts, and taking one of those parts. Or we can think of it as iterating instead of partitioning. And we could say 3/8 is the amount we have when we take 3 copies of 1/8. So are we splitting things up, or are we copying, or are we doing a combination of both of these? So partitioning and iterating are important ideas in fractions. Okay. So I want you to think about 5, 6 as partitioning versus iterating, how you would describe it. I'll go back, just remember 5, 6, okay? I'll go back to here. So how would you describe 5, 6 using partitioning and then using iterating? Okay, you're all right? I'm guessing you said something like this. With partitioning, you said 5, 1/6, where 1/6 is the amount you take by taking a whole, cutting it into 6 equal parts, and taking one of those parts. Whereas iterating is just 5, 6 is the amount we have when we take 5 copies of 1/6. And I love this copies of idea. Does it remind anybody of anything that we've already talked about so far? Yeah, Amanda's shaking her head. Yes. What were we talking about with copies of before?
Isn't it division? Or was it multiplication? I can't remember. No. It was the divisor and dividend, right? The groups of, and then the copies, right?
It was both. We did it with multiplication and we did it with division, right? Talking about copies and groups and size of groups, same kind of thing. So it's nice because we're going to keep that model consistent, this copies of idea. Okay. These are the Common Core standards that we have, or Arizona State standards, just so you know. Understand that a fraction 1/b is the quantity formed by one part when a whole is partitioned into b equal parts. Understand that fraction a/b is the quantity formed by parts of size 1/b. Do you see how that's exactly what we're talking about in our standards? So like copies of works very nicely for our standards. Now, also notice that it says, understand a fraction as a number on the number line. How many of you remember putting fractions on a number line? Not very often. We didn't do it. We didn't do it enough for sure. Guess what we're going to do a lot of? Put fractions on number lines. It's very important that students understand, because remember that conversation, is it one number? Is it two numbers? Is it three numbers? If it's one number, it holds an exact location on a number line, right? When we get confused and we think of it as two numbers like 3/5, okay, where's 3 on the number line and where's 5 on the number line? But where's 3/5 on the number line? It's in a very specific location, yeah? So this is super duper important. And then explain equivalence of fractions in special cases and compare fractions by reasoning about their size. Anyone learn about benchmark fractions? Benchmarks, 1/2 is a good benchmark fraction, right? Is this bigger or smaller than 1/2? For example, you think the 4-step method is gone, right? It's not gone. Let's say we're adding these two fractions. And by the way, those are naked numbers. I have no context here. But if you're working with a kid, you might go, how on earth would I use the 4-step method with this? Okay, well, you'd start, understand the problem. What is this asking us to do? Well, it's an addition problem, so it's asking us to put these values together and find the answer, right? Okay, so what could my conjecture be? Well, I know that 1/3 is a little less than 1/2, and I know that 4/5 is almost 1/2, right? So if I combine them, where should my answer be? What two numbers should my answer be between?
Between 1 and 2.
Yeah, it should be between 1 and 2, right? I better get an answer between 1 and 2. I shouldn't get an answer less than 1, and I shouldn't get an answer bigger than 2. That's huge for kids to understand, because some kid in your class has a broken foundation for fractions and they go like this. And if they followed the 4-step method and thought about their conjecture, they would go, oh, well, that can't be right. Because 5/8 is between 0 and 1. So there's no way that's the correct answer. Do you see what I mean? Now, can you contextualize a problem like this for students to understand more? Sure. Teachers love pizza, candy bars, right? They love those kinds of things. So, but you could also do parts of bags, right? You ate 1/3 of a bag of this. You ate 4/5 of a bag of this. How much did you eat altogether? Well, you definitely ate more than one bag, right? So it's nice to think about these things. This is what I want you to do right now. And then I'm going to put you in your breakout rooms. A whole sheet of paper, right? You have a whole sheet of paper. You can just draw it on your paper if you want. But here's your whole sheet of paper. This piece of paper is 4/5 of a bigger sheet of paper. This sheet of paper is 4/5 of a bigger sheet of paper. Could you fold your paper, or you could draw a line, in a way to show what 3/5 of the bigger sheet looks like? Think about that again. So you have a sheet of paper. That is 4/5 of a bigger sheet of paper. Can you fold your sheet of paper in such a way that you can easily show me what 3/5 of the larger sheet looks like? Again, you can draw pictures if you want, instead of folding the paper. I'm going to give you a minute to think about it. Then I'm going to put you in your breakout rooms with your new partner. And somebody's partner isn't here. I think it's Elena's. Kelsey isn't here. So I put you with another partner pair. So just know, Elena, your partner's not here. Okay. Okay, everybody knows what the question is now, yes? Okay, I'm gonna put you in your breakout rooms to discuss this with each other, okay? And then I'm gonna broadcast a message on the next thing I want you to do, okay? And I'll try to come visit you.
Roxanne, I didn't get a notification to go to my breakout room.
Sorry, Hannah.
No, you're.
And you're with Brianna.
Mm-hmm.
We'll put you, weird. Okay, you should get it now.
Thank you.
Yep. Hello, some of you are back. Alyssa, Essie, Jessica, did you guys figure it out? How you would fold that paper?
Oh yeah, totally. I tried to fold the paper myself and I couldn't even fold it evenly for 5. So that's where it went wrong. And I was like, hey, I'm not going to do that anymore. Then I drew the picture above here and compared the two. And I was like, well, if you're thinking about a full sheet of paper, you could just fold it in half and then you would be able to see the 3 out of 5. But that's all I've got so far, but that's probably not logical.
Interesting. No, this is a fun problem. Hopefully you got to the number line part. Did you get my little broadcast message
Yes.
that you did a number line? Excellent.
That one was much easier than the other one.
Yeah, I thought you would appreciate that. So let me go over briefly. Maybe some of you had this. If this was your whole sheet of paper, the original sheet that we started with, and we knew this was 4/5 of something, yes, of a bigger piece of paper, then how could you fold this piece of paper so it would show you 3/5? So here's my piece of paper. This is 4/5, yes? So this is 3/5.
How is it 3/5 when there's only 5 slots and there's only 4 slots?
All right, who's gonna explain to Alyssa, how is this 3/5 when there's only 4 pieces here? Anyone?
It's because you said the paper was 4/5. So the paper represents 4/5 already. So we split it up into the 4 pieces. So each piece is 1/5.
So
And then we took away 1 piece to have the 3/5.
I'm over here thinking, trying to combine all these sheets.
Well, the problem is you guys really are used to the part whole model, right? You're really used to seeing the whole piece. But what if I don't give you the whole piece, right? Can you still do it? Amanda's explanation was excellent. Okay, I'm hoping your number line looks something like this. Yes? So hopefully you have a 0 on your number line. Hopefully you have 1 hole, and then you should have 2 holes. Now you could have labeled them all and said this is 1/3, this is 0/3, right? 0 copies of 1/3. This is 1 copy of, this is 2 copies of 1/3. Nice that you can see them. There's 1 copy of 1/3, there's 2 copies of 1/3. This is 3 copies of 1/3, 4 copies of 1/3, 5 copies of 1/3, and this is 6 copies of 1/3, which is also 2. Nice.
So we're just never going to do mixed numbers then, right?
No, I didn't say we're never going to do mixed numbers.
When I see the 4/3, I'm like, wouldn't that be 1? And that's how I got it on the number line. But before that, I'm like, how do I show that again? So I had to like rethink, okay, Alyssa, that's not really that. It's really this, but it's showing it that way.
Wait, are they not the same?
No, they are. In my brain, I'm thinking you can't have 4 more than 3. But then if I think, oh, that's improper, then it actually means 1/3 more than 1. Then I'm like, oh,
absolutely.
Then
yeah, you're just going to retrain your brain. I didn't say we're never going to do mixed numbers. I like mixed numbers.
Sorry.
Right? I like mixed numbers, but in specific circumstances.
Gotcha.
Right? Okay. So you have a Jamboard activity, right? And you're going to talk with hopefully you talked with your partner already. You're like, hey, dude, how busy are you this week? Right? Because that was your partner, except for you, Elena. Sorry, Kelsey wasn't here, but you can reach out to Kelsey. So, and so you were talking about how are we going to do this? I'll show you what the Jamboard looks like. It's a super fun Jamboard. I like it. And some of you struggle writing on a Jamboard. I know you can write on paper and you can put an image inside a Jamboard, right? So if you want to do that, that's totally fine. Sorry, I'm trying to click on the Jamboard and it's not letting me. Let me put it in the chat. I just lost all of you. Story of my life today. All right, so here's the Jamboard. You guys can make a copy. I'm going to click on it. My chat has gone mad. Has your chat gone crazy? Like my chat is just scrolling. Okay. Can you still see my screen? Okay, this is what the Jamboard looks like. Here's the first page. You're each going to make a copy, like a pair of you make a copy. So you're going to show 1/4 in each of these different squares. I don't think that'll be hard. Be creative. The next page says, okay, here's 4/5. This point that I mark right here is 4/5 on the number line. I want you to locate 1 3/4 on this number line. Yes? Tricky? Okay, and then here's some help on how to do that. Then there's another one. Here's 1 3/8. Oh, look, there's a mixed number for you, Alyssa. There's 1 3/8 on the number line. I want you to show 9/32 on the number line. It's fun stuff, man. Let me tell you. Okay, then please, please, please look at this. Do you see how it says the rectangle represents 3/4? Do you see that right there? So do not pretend this is a whole, because it's not. This is only 3/4. Yes? Amanda's shaking her head. Yes. I think Amanda's your new consultant if you need assistance. Okay. Alyssa's like, dial me up, man. I'm gonna call Amanda. Amanda, would you be willing to help people? See, look at that. Okay. And then here's a nice one. They're both trying to approximate the location of 11/30. They're given 0 to 1 on their number line. Here's David's thinking. Then here's Vanessa's thinking, and you're following their thinking, okay, and marking it on the number line. And I think that's it. And then why can both of them be used? So you're going to answer that. You're only going to turn in 1 Jamboard per team for a partner pair, and then you have a Google peer evaluation. If you don't fill out the Google evaluation, your grade is docked 10%. Okay, so make sure, yeah, thanks, Alyssa. I was going to say like 90%, but I didn't. Okay, so make sure you do that. I was hoping you would have more time with your partner pair, but you don't. Look at all these assignments. Don't start crying. They're not too terrible. The first one's a video assignment. Won't take you long. The rational number homework's due Wednesday. Please make sure you get on that. That's a thinker. Please follow the directions. If you have questions, let me know. Your fraction rules worksheet. That's fine. That won't take you long. You can start on it if you want, or we'll go through it with the slides as well. The digit problem is a discussion board. It has to do with divisibility rules from last week. It can be a doozy if you're not careful. Okay, so please spend time on step 1, understand the problem. Okay, you can do it. I know you can all persevere. The next one we're doing in class, ordering fractions. Do you see how it says in class activity? If you're there that day and you're participating, you're going to get all those points. So nothing you have to worry about. Tomorrow, we're doing the home activity exploring the unit, but we might not get through the whole thing. Okay, so it's not due until next week, but it's kind of a doozy for some people. Not for everyone, but for some, so be careful. And then your partner fraction Jamboard activity and the partner pair evaluation. You do have 3 more assignments, like MOER assignments. There is an optional assignment. It doesn't count towards your grade. The last one on this list, more fraction operations homework, that one's not due for 2 weeks because it has all fraction operations in it. But I know some of you will get bogged down, so I just opened it early for you. Okay. So that's your overview of the week. I know it seems like a lot, but it's very doable, I promise. And it will really get you thinking of things. I'm going to put your exit ticket in the chat. so I make sure you get to leave on time. And then I'll answer any questions you guys have. If anybody wants to go back in their breakout rooms to talk to their partner, I can open them back up again. So just let me know, and I can leave them open till 1:30 or so you can chat with your partner. Otherwise, I'll just be quiet while you do your extra ticket. I don't know why that's freaking out.